Hello and welcome to my YouTube channel. This is John Amabile, author of the book Changing the Worlds, the for-profit plan to mine asteroids and terraform 2 planets in 1 human lifetime. Tonight's video will be about the benefits of nuclear thermal rockets compared to chemical rockets. The energy held in uranium is 3 million times the energy held in the same amount of rocket fuel. I want that to sink in for a moment. 2 objects of exactly the same mass, and one of them can perform 3 million times the work as the other. Not bad, huh? America also has a huge nuclear waste opportunity. We have more than 68,000 tons of nuclear waste, which we plan to spend $100 billion to bury, not simply on our home world, but in our own country. This material is not useful for our nuclear reactors, which require uranium at 100% energy capacity. Nuclear waste is uranium that is run down to 95% energy and won't work in the reactor the same way. So a nuclear thermal rocket full of nuclear waste is 2.85 million times better than a chemical rocket. Finally, when the fuel cells on the NTRs burn out, they can be transferred to a propellant station in orbit around a distant asteroid. Every neutron that radiates out can generate heat and help to electrolyze hydrogen propellant from water. We can use all of the energy without risk of pollution. The nuclear thermal rocket does still require hydrogen propellant. Only half as much as the chemical rocket needs fuel, but still a concern. So where in the solar system can we find nuclear thermal rocket propellant? It's basically the most common element in the solar system, hydrogen. I've done a separate video on Transastra's technology that can extract water from virtually every asteroid in the solar system. How difficult is it to extract? While Transastra's process uses sunlight, any application of heat would work. Normal smelting procedures to mine any asteroid would release even trace amounts of water. We can melt out the water, then use electrolysis to split the hydrogen and the oxygen. There are many elements that contain hydrogen. Ammonia is NH3, for example. Each time a ship mines an asteroid, they will start by melting out water, or any other hydrogen-rich element, and restoring their depleted propellant stock. To be fair, I must point out that many of NASA's rockets also use liquid oxygen and hydrogen as fuel. This is what Transastra is working on right now. So what is the difference of extracting hydrogen and oxygen for NASA's chemical rockets versus only using the hydrogen as propellant in a nuclear thermal rocket? Well, the hydrogen and oxygen have to be combined just under the right conditions in order to combust. This requires 2 sets of pumps, 2 sets of pipes, and a large number of ways those systems interact with each other. This also involves a large number of moving parts, which means mechanical wear, which means maintenance. How many maintenance depots do you think we have on the wrong side of Mars? And all of this so that we can go half the speed of a 46-year-old engine. A nuclear thermal rocket is just uranium with perforations in it. We can heat up or cool down the uranium by rotating neutron moderators toward or away from it. About as complex as a foosball table. Then we run hydrogen through the perforated uranium, which transfers heat from the uranium to the hydrogen, and then we accelerate the hydrogen out of the rear of the rocket using a simple nozzle to channel the exhaust. By this simple method, we get twice the speed of a chemical rocket and 3 million times the energy capacity. We have fewer moving parts and less complexity. Any nuclear thermal rocket propelled system will have a simple machine that can separate hydrogen from water or ammonia, restocking the propellant at each stop. As long as we have a hydrogen source in high Earth orbit, we can propel our NTRs out from Earth. Once they arrive at 433 Eros, or 16 Psyche, they can mine ore, remove hydrogen, store it as propellant, and fly back home. Eventually, we'll bring large ice asteroids for propellant back to high Earth orbit, but Transastra's technology means that we need very little propellant to get started as long as we're using a nuclear thermal rocket. Since space travel involves traversing huge distances over years, an NTR might go on a multi-year mission to 15 different asteroids, taking on additional hydrogen each step, but with no additional fuel or maintenance. The speed increase also cannot be overstated. When we travel from London to New York, we don't have to worry about New York flying away from us at 14 kilometers a second. Objects in space are perpetually moving. A 2x increase of speed does not mean that you can reach asteroids A, B, and C in half the time. That may mean that you can reach these asteroids at their closest approach a month from now, instead of flying 6 months of food, fuel, and water to meet them wherever they'll be in 6 months. If there's a delay in the launch, you have to wait another few years until the window opens again. With an NTR, your launch window is twice as big because your velocity has doubled. The cost of the trip is half because the crew will spend less time in space. The health risks to the crew could go down by a factor of 10, since radiation damage accumulates with time. The confidence of our investors is harder to measure. There's also gravitational drag from the sun, which equals a loss of money for the ship to compensate. The further back we go in the solar system, the greater this drag factor. Even if we move between 3 objects in the main asteroid belt, the sun will be pulling our ship toward the center of the solar system at every step. Going twice the speed means half the gravitational friction, which could make the trip 4 times as fast or save a fortune in propellant and engine wear. Finally, and perhaps most importantly, is the confidence of our investors. Would you prefer to invest $1 million today to get $1 billion in 3 years? Or would you want to get your $1 billion in 1 year? We've barely scratched the surface with this technology. When I write nuclear thermal rocket, really what I mean is the solid core nuclear thermal rocket, flight tested, even crash tested by NASA in 1971. The liquid core design is more like uranium soup, with hydrogen being pumped through it at a 50% increase in speed. The gas core is more like a uranium light bulb with hydrogen flowing around it. This system is twice the velocity of a solid core nuclear thermal rocket. For a multi-year mission, that 50 to 100% increase in speed could be a huge difference in price. So to compare all of these systems, we see that a chemical rocket has a specific impulse of 452 meters per second. A solid core nuclear thermal rocket is 850 to 1,000 meters per second. Liquid core is 1,300 to 1,500 meters per second, and a gas core is 1,500 to 2,000 meters per second. In my plan, we start with solid core nuclear thermal rockets using transastor technology to get propellant as we go. We make our first $30 billion by mining arrows. Once we get the first infusion of cash, we can accelerate our research and development to build the liquid core and the gas core designs. We can also send solid core NTRs on longer missions to bring back thousands of tons of hydrogen propellant from the main belt. Since hydrogen is a liquid, it would simply dissipate into the atmosphere if it accidentally came down to Earth. The platinum on arrows can get everything started and is very reachable with a solid core NTR. 16 Psyche, 21 Lutetia, even adding more time to how long we can work on arrows, all of these things will be benefits of having more advanced nuclear thermal rockets. Cutting these flight times down will be essential both for simple economics of spaceflight as well as willingness of the crew to be away from home that long. Chemical rocket velocity has made little progress in 80 years. We know how to double NTR capability, and we haven't put the most basic design in space yet. Since there are quadrillions of dollars to be made in space, a few billion to get there faster will be a simple enough investment. Imagine how slow it would have been for America to grow without steam-powered railroads, or for Australia to develop without steam-powered ships. Without nuclear thermal rockets, Solar System 1 is just an expensive photo opportunity. Please like this video, go to my website, subscribe to my channel, and look for me on Facebook and Twitter. If you're really interested, my book is for sale on my website and on Amazon. Thank you, and have a good night.